Hello and welcome to our final project video. This is our game. We start with our included header files necessary. Our first order of business is this struct here, which we named player. It holds all the data needed for our player in the game to function. It has the player's health points, what round we're on, his position in the array, points to win the round, etc. Then we have a teacher array, which keeps track of all the teacher data we need, as we have more than one teacher in an array. This makes it easy to keep track of them all. We then have all our function prototypes, which we will get to shortly. We then hop into our main, where we declare our player, and then we set all his initial values. We declare constant ints to set our array size. We make a teacher array of the same, a 1D array of the same size, of an equivalent size, I guess. And then we dynamically allocate that array.
Allocate.
Allocate that array. And then we create an int called teacher count to keep track of how many teachers we have. And then we initialize our map array. We initialize sran so we can have random functions. We then start a while loop, which will actually run while we're alive. We set our points equal to 0, because you don't start with any points. We generate a playable map. We print that map once it's generated with all the info that is provided to it. We then start a second while loop inside of that while loop, and this while loop will run while you're alive. And yes, you have to be alive for this loop to run, and you have to be under max points for this loop to run. It also keeps track of how your hall pass functions, which we will explain later, and when your hall pass ends and when you have it. It then allows the player to move. We have a clear screen function here to try and cut down on nausea when playing the game. We print when you have a hall pass, so you know when you're powered up. The teacher then moves, and then if your health goes below 0, we exit out of this while loop. This while loop fails, and you get the end game printf. If not, this keeps going until you collect all the points for the map, and then you go on to the next stage, and this loop will run indefinitely until you die. So the goal of the game is to get to the highest round possible. And then every time you beat a round and you start the next one, a new teacher will spawn. So each round you have one extra teacher you have to avoid.
And you start with 3.
Yes, and we start with 3. So there's 4 movable players at all times. We then get to our first function, the void map walls. This will fill the array boundaries with the wall that the player can't leave, so you are confined to a 15 by 15 space. It is fed by copy the constants we established, so it knows how large the array needs to be. We then fill the array with, and since the array's a pointer, it changes the main array. We then fill the entire array with blank spaces, and then we make the left side of the array at 0, the right side of the array at 15, and the top of the array at 0, and the bottom of the array at 16, all asterisks for the wall. And then we generate random walls that make the map different every time by this rand function here. We then print the map with this function, which gets the constants in the array again, and it also gets the player struct data. It will print what round you're on above the map. It will print the player's health every time. It will print how many points you have out of the max points, so you know how many you need to collect. And it will also print how many steps you have left remaining for your hall pass, assuming you have the hall pass active. And then it will print the rest of the array, which is filled via these future functions down here. We then have the hall pass array, which spawns hall passes on the map. These are what you have to collect for your power up. It will spawn in 10 of them, and it randomly places them everywhere that's not the walls. So it can't replace the borders, and it won't replace the random walls. It won't replace the student, and it won't replace the teachers. So if it meets all those conditions, it will put an H in the array where they decided to spawn. And Nick will take it from here.
Yeah, so we then get to the teacher spawn function, which is obviously mainly used to spawn the teachers on our map. It spawns the number of teachers commensurate to the teacher count that's stored in the player struct as well. And they're spawned at random open positions on the map. So for each teacher, it sets their row and column. It writes a T onto the map and then initializes their undertile part of the teacher struct, which is just going to keep track of what they're walking onto. It becomes important in the movement because it lets us keep the energy drinks and hall passes on the map if the teacher actually goes onto those. We then get to the energy drinks function. This resets your max points to 0, loops through the map, and turns every remaining empty tile, which is not a wall, player, teacher, or hall pass, into an energy drink. And then it counts how many drinks it actually placed and stores that in max points back in the player struct so the game knows when the round is complete and when the player will get them all. We then get to the flood fill function, which is probably the most important function we have. It's using recursion to check reachability on the grid. And you may be like, well, why do you need this? We have randomly generated maps, so there is the chance that an energy drink gets spawned in an unreachable position. This function, using what it does, will make sure that that can't happen. It's going to check to see how many playable spots there actually are on the map and store the every non-wall tile is actually stored in the visited array. And it's just trying to basically find how many spots the player can actually reach so we can use that information in the next function, which is the generate playable map function. It uses a couple of our other functions inside to build a complete and winnable map for each round. Inside the do and while structure, it basically will reset the teacher count, call map walls, place the player at 1-1 or the initial position, calls teacher spawn, hall pass, and energy drinks to start filling it out. It clears that visited array I mentioned, runs the flood fill from the player spawn, and then scans the map for any energy drinks that couldn't be visited inside of that. And if there is unreachable ones, it'll actually throw the map away, respawn it. This keeps happening until there's a winnable map. So it's just a way to make sure a random generated map actually can be beaten. We then have our player movement, which prompts the user for W, A, S, and D input to move the player in obviously each of those directions. For each direction, it won't let you move into a wall or a teacher. It'll print a short message to just make sure you know that you couldn't do that. If the target tile that you're moving onto is a hall pass, it'll give that value back to the player struct, turning the hall pass on and setting the hall pass counter to 10. If it's an energy drink, you'll increment the points. And then it'll update the map every time by clearing the old player position and moving the S, which is the player, onto the new position. And if anything is entered besides WAST or WAS and D, it prints a warning and leaves the player in the place they were. So for our teacher movement function, this is probably one of our more long functions. It needs to be complex because they're following the player. Long story short, the teacher movement is going to, as long as the player doesn't have movement or have a hall pass, it's going to move the teacher one step closer to the player. It has its own array that stores those movement possibilities, either one move up, one move to the side, or not moving at all. And it'll compute a desired row and column moving toward the player, then trying those 3 possible moves I kind of mentioned. It ignores any move that would go into a wall or another teacher, so they can't just overlap. And if it lands on a player, it reduces a life from the player, prints a message, and if the player still has lives remaining, it'll reset their position and then restart the whole map and round. Normally, when they move, it'll restore the tile under the position of the teacher. So basically, when they move on to an energy drink, it's stored in the under tile part of the teacher struct. Then when they move off that position, it'll put it back down. And that can happen from the energy drink and the hall pass. And it's just a way to make sure that we can not remove energy drinks arbitrarily so the player can actually win the game. And then if the player does have a hall pass, they just don't move at all. That's kind of how we made the function work. Finally, we have our clear screen function, which basically just prints a bunch of new line characters to push your old output off of the screen. It didn't really fully work. I mean, it's still a little bit vomit inducing when you're playing, but that's partially due to limitations of CLion's IDE. If you used a regular terminal, you can actually legitimately clear the screen. We can't. It's in CLion, so this is probably the best way we figured out how to do that. Maybe there's better, but That's pretty much most of the functions, and using the structs obviously helped us a lot. Now we're going to show you how the game actually works.
Yes.
So
So,
Casey's going to take over and show you his skill as it comes to playing this game.
absolutely, I'm a professional. I'm in the big leagues. So this is how it looks. You have, I guess I shouldn't use my finger. We have the round counter here. We have your lives here, and we have the points here. And you move by uppercase or lowercase WASD. You win by collecting all the periods, and that's how the clear screen looks. It makes it less nauseating, but just because of the oh, I died there. A teacher got me thanks to our advanced teacher seeking algorithm. As you can see, our lives iterated down, and our map reset 0 points again. But as you can see, every time we collect an energy drink, the point iterates up. And then if we get to hall pass here, it says we found a hall pass, or has our now remaining turns of the hall pass, and as you can see, the teachers will not move, hence making the hall pass good.
The dynamic HUD. It
Yes.
only shows up when you have the hall pass.
It's true. Now that we're out of moves, the HUD is gone. We're collecting points. We're about to get caught by another teacher. Oh, I didn't enter. Oh, we didn't get caught. I'm so good. And we got caught again.
You got
As you
cooked.
can see, our life went down. I won't. It would take far too long to actually beat the map for this video, so I will get caught again here. Now that all the, well, I guess I'll try to move into a wall here. Oh, but we got caught, and this is our cool animation scene. You're coming with me. You're going to detention. You lost. I'll start again just one more time to show that we can't move into walls. If you try to move into a wall here, I think I actually just added to the code on accident.
It's okay. Just
Hopefully it works.
keep it going.
W, yeah. And then the map will just regenerate in place, but every time you move to the wall, the teachers will still move, so it would behoove you not to do that, but you're not able to move out of the array. And that is our game.
Thanks for watching. Please like and subscribe. Sorry, that was cringe.